Hello, good evening. Welcome back to our October week 2. Okay, hi Gabriel, there's only you currently. Right, so where were we? I think we finished our chapter 8 already. I think. Okay, we finished all our radioactive stuff, if you still remember this. I think I finished the exercise 2, right? There's not much to talk about lah. Okay, more or less finished already. Okay, so then if that's the case, then I'm not gonna repeat this already lah. It's a very simple chapter. Okay, or rather a very simple sub-chapter, because we learned this, okay, the types of isotope last week and what are their uses in daily life. Okay, what you use for cancer, okay, what you use for this and that. So okay, so we are going to chapter 9 today. Okay, let's go to chapter 9 today. Okay, let me erase something real quick. Right, so chapter 9. It's weird, where's everyone today? Okay, let's go to chapter 9 today, which is our alloy. Right, very important sub-chapter, because this part, good news, it will for sure be coming out in exam. Okay, I will put a star here. Okay, good news, for sure will be coming out in exam, and it's really, really easy. Give me a moment, give me 5 minutes. I need to go to the toilet real quick. Okay, hello, sorry for that. Right, so let's begin. What is alloy? Very important sub-chapter, or also very, very easy to study, right? Because this is a very straightforward thing to understand. No twisty twist and turn stuff here. Right, so first of all, what is an alloy? Okay, alloy is a mixture of several types of metals. All right, so we take a few metals, we mix it together, and we created alloy. Right, so alloy has been used for thousands of years. Right, that's why you have the Bronze Age. Okay, the Bronze Age, or we call it Zaman Logam lah. Okay, that's when humans, we discovered actually mixing metals make them better. Right, so why mix metals though? Okay, why mix metals? Okay, first of all, let's look at point number 2 first. Most pure metals, they are soft and can corrode easily. Right, when we discovered iron, okay, let's take iron for example. Okay, when we first discovered iron, we realized something. Irons, they are very easy to shape. You can bend them and do anything you want. But here's the thing, they are too soft, all right, which makes them very very unsuitable for farming and things. And not to mention they corrode easily. Iron, they rust. Right? Iron, they rust. So what makes us humans better than other animals is that we can create tools that can last. Okay, this is why we evolved. Right? So, and we discovered alloy. So first of all, what is the process? The process of forming alloy, we call it alloying. As straightforward as you can get, okay, alloying, okay, to make alloy. So why make alloy? First, number one, make alloy. This is to increase the hardness. Bronze is harder than copper. Copper is the pure metal. When we mix it, we can make bronze, and bronze is much harder. They can last longer. They make better tools. And then, of course, they prevent corrosion. Okay, they stop rusting so that your tools doesn't spoil. And then next is to improve appearance. Okay, when we start to appreciate the art of making things, we know how to make pretty. First, we make things, then we make pretty things. All right. So when we are making pretty things, we want the pretty thing to last. So alloy is also to improve the appearance. Okay, to make it harder, last longer, okay, prevent corrosion, and to improve the appearance. All right. So this is the very straight and simple point of alloy. That's the point, the advantage of them. All right, so that you have a few types of alloys here. Okay, you have a few types of alloys here. Please highlight bronze and brass. Okay, we are focusing mainly on bronze and brass. Okay, why? Because these two, they are the most common in exam. For sure, they will ask bronze and brass. Right, so let's go into these two first because they're important. So bronze and brass, they are the same, made from copper. Please don't memorize the percentage. They are not asking you for the percentage. You just need to know what's the ingredient. Okay, what makes bronze? That will be your copper plus tin. Okay, copper plus tin. All right, so what is tin? What is tin? In BM, we call it timah. I'm sure you heard of this. I'm sure you heard of this, right? Which is your biji timah lah. Okay, yes, tin can get or biji timah. So timah, timah. So the British came here for this, okay, which is to get our tin ore, to steal our tin ores and our money, because tin used to fetch a very high price. Used to lah, but we don't use tin anymore. Right, here's the thing, when we say the canned drink, we call it tin can. Okay, we call it tin minuman. Actually, we don't use tin anymore. We use aluminium. Okay, we use aluminium because tin is just very impractical to use. Okay, they're heavy. Okay, they increase the cost of transport. So now we just use aluminium. Right, so bronze is just tin plus copper, which makes them hard. Okay, they are resistant to corrosion. Okay, they are attractive. Okay, like I said. So what is bronze for? As you know, bronze is used to make metal. You use it to make metal. Okay, which is your bronze. Number 3 lah. Ranking number 3, you get bronze lah. You can use it to make coins. Our 1 cent is made from bronze. I mean, if you still remember 1 cent, we don't use it anymore. Okay, the old 1 cents, they look brown. Okay, so they are made from bronze because they're cheap. We don't make them anymore because it makes no sense. Here's the thing, for us to make that 1 cent coin, it costs more than 1 cent. Right, which makes it really stupid. That's why we stopped making it. And of course, metal sculpture and monuments, these belong to the same. The Statue of Liberty is made from bronze. Okay, the Statue of Liberty is made from bronze. This is why the original color of your Statue of Liberty, they actually look brown. There. Okay, this is like what, hundreds of years ago, a few something years ago. There, they used to look like this, and then after years and years and years of oxidation, they just kind of turn green. Right? Yes. Well, not to say corrode lah, when they oxidize. Okay, when bronze oxidize, they turn green. This is why, right? Okay, when you find a new, okay, let's just say coin, from China Qing Dynasty, from the Qing Dynasty, when they found those old coins from the old emperors, they will usually look green. Okay, dark greenish. That means they're oxidized. All right, so that's what your bronze is. When they oxidize, they turn green. This is why your Statue of Liberty, they look green. So this is your bronze. And then next, brass. Brass is when I add copper to zinc. Okay, when I add copper to zinc. Right, so this is almost the same thing. Brass is almost the same thing. They can be used to make coins as well. Oh, our 20 cents and 50 cents are made from brass. Okay, they're made from brass. We use it to make musical instruments. In fact, in orchestra, there's a section of musical instrument called brass. Okay, when we say, okay, we have the strings, which is violin and viola and cello. We have the woodwind, which is the bassoon, the flute, the clarinet, things like that. And then we have the brass, which is your trumpet, trombone, French horn, tuba. So there's a section there, right? So we call it brass. So not to mention that our keys are actually also made from brass. Just in case you don't know, our keys, right? Okay, you go and look at your keys. If your key is still new, it looks silvery, right? It kind of looks silvery on the outside. But after you use it for years, your old keys, your older keys, they just kind of look, the silver starts to peel off and they kind of look yellow, isn't it? Because your keys are made from brass. Okay, they are coated with a layer of zinc to make them nicer. But once the coating is off, you are left with this yellow color key, which is your brass. Right? I mean, why do they use other metals? Because brass is cheap. Why can't they use stainless steel? You can, but it will be really expensive. Okay, and not to mention, oh, here's the thing. Why use brass to make keys? Because they are easy to cut. You see, when you're making new keys, they use a machine to cut, to shave your key, right? Why do they use brass? Because brass is easy to shave. Brass is soft. I mean, not as soft as copper, but it's still, compared to other metals, they're very soft. That's why we use brass. Right? So these are the two very important ones in your exam. So you should know their ingredients. The function, you can kind of guess it yourself. You see bronze and brass everywhere, isn't it? Next, okay, let's begin with the first one. Okay, let's look at steel. I'm sure you heard of this word steel, right? Okay, heard of the word steel. So steel is majorly made from iron. You know what iron is, as I said just now, we discovered iron like many years ago. We used to make tools. And then we somehow realized when we heat iron with carbon, which is any organic material, because carbon comes from organic material, your sheet has carbon. So when they are mixed together, they just kind of become stronger. Okay, we realize this. They just become stronger after they mix with carbon, because after mixing with carbon, we call it steel. Okay, we call it steel. Or sometimes for older generation, they call it cast iron. They call it cast iron. We use it to make what? Pans, right? This is your cast iron. Okay, your cast iron. So these are steel. Okay, these are steel. Right. Here's the thing. Steel, they will still rust. Your cast iron, they can still rust. It's just that they rust much slower. They rust much slower. And why use steel? Because they're cheap. The main thing about steel is they are dirt cheap. That's why your buildings, okay, buildings require a lot of steel, right? Your car is made from steel. Is it a good heat conductor? It's a heat conductor, but it's not a good one. Compared to copper, of course, copper is much better. All right. The thing about steel is it is very strong. It is very strong. That's why we use it for construction. We use it for vehicles. Your car is made from steel, right? If you scratch your paint on your car, does it rust? Yes, it does. Yes, it does. So steel, they will still rust. Unless you use a better steel, right? What happens when steel are mixed with chromium, molybdenum, and vanadium? Okay, that means all the weird metals you will form a much more expensive steel. We call it stainless steel. Right? This is the thing found in your spoon and fork, your cutleries. I'm sure your house, your mom's pot is made from stainless steel, right? So because they call it stainless because they don't rust. Well, of course, it's much more expensive lah. I mean, we can't make our car using stainless steel because that would be a lot of money. That would increase the cost. That's why they would rather use normal steel and they paint it. It's much cheaper that way, right? So this is your steel. Okay, they are just mixed with like carbon. Okay, so fun fact, actually stainless steel, right? They have many grades. Okay, they have many grades. If your house uses a slightly more expensive pot, we call it a 904, a 304 steel or a 316 steel. Stainless steel has different grades. Some stainless steel, they will still rust and corrode. But if you use steel like stainless steel like 316, that's like one of the most expensive stainless steel because they can withstand corrosion very strongly. Okay, this is why we use it in our pot. Right, so that's your steel. Next, pewter. What is a pewter? Pewter is mainly made from tin, you see. This is basically from biji timah lah. Biji timah is tin one. So we use this to make our... Okay, so what's the use of pewter, by the way? Pewter, they are only for decorative purpose. Okay, we use it to make decorative items. In this case, in Malaysia, right, there's only one company selling it, which is Royal Selangor. So this is Royal Selangor. So Royal Selangor, they make pewter. I mean, it's not as expensive as last time already, but they still do make pewter. And they kind of make all these cool designs, you see. I think they have one in Pavilion. Okay, Pavilion Bukit Bintang, they have this thing. They sell, ornaments, they sell decorative items. Sometimes they even collab with movies. You see, they have the Royal Selangor Marvel collection. I mean, it's not expensive. It's 800 something, okay, for a metal figurine, you see. But yeah, it's for collection purpose lah. We don't use this anymore for food canning or anything lah. They are just for decoration. Pricey. I have seen plastic ones for much higher price, so I can't complain, right? Anyway, so this is your pewter. So if you want to look for pewter ornaments, that's the only thing you can go for. They can also be used to make trophies. Okay, some trophies, they are made from pewter as well. Right, so next, moving on, we look at duralumin. Whenever you see the word alumin, this is aluminium lah. Right, so duralumin is used in airplane because they are lightweight. Okay, in any aircraft, they will use aluminium because they are lightweight. Because a plane needs to fly. Right, you might say, sir, why can't cars use duralumin? Because you see, duralumin is not as strong. Okay, it's not as strong. You have to know, cars, they need to withstand accidents. Right, they need to stand accidents. So whenever there's a car crash, your car need to tahan the crash. Whereas plane, they have no such problem because even if I use steel to make plane, once they crash, you also die one. Might as well they make it light. Okay, so I'm not saying that cars, they don't use duralumin. They do. Only sports car. Okay, only sports car. If you buy a sports car that focuses on weight, for example, you buy a Lexus LFA, okay, if you have the money, or if you buy like McLaren, you see. Okay, here's the thing, McLaren, unlike Ferrari and Lamborghini, is all about horsepower. Okay, but McLaren is about that genius engineering that makes the car as light as possible. So if you were to buy a McLaren, that's why they're very pricey, the whole body is made from duralumin. The frame is made from aluminium. Okay, this is why when you crash a McLaren, it's usually done. The car is total, it's forever lost. Okay, but you won't die. Okay, you won't die. Why? I know aluminium is very soft, but you see, for sports car, right? In the middle, there's a frame, we call it a monocoque. Okay, we call it a monocoque, which is this thing, a monocoque. You look at sports car, they have this frame in the middle called monocoque. I mean, normal cars, we have this too, but you see, this is a sports car monocoque. Can you see the front and back is aluminum, the silver part? And can you see the middle is black? You might say, why is it black? Because in the middle, it's made from carbon fiber. Okay, because they know that aluminum is very soft, and anyone drives sports car, they're going to drive it fast. So this thing should be able to stand crash, right? So to make this thing much stronger than steel, they will use carbon fiber, which is why, okay, let me show you carbon fiber monocoque. This thing is super lightweight and is super strong. Well, not to mention super expensive. They only use it in F1. They only use it in F1 or certain, supercars or hypercars. Okay, you see? It's black. Okay, they are very lightweight and they're very strong. They are as light as plastic, but they are stronger than stainless steel. They're stronger than steel. So, well, you are paying for a sports car, like, I don't know, 3 to 4 million ringgit. Of course, they're using this material for you. This is hand built. Most sports cars, they are hand built, not just mass produced, right? So this is your duralumin. Okay, so the point you need to focus is bronze and brass, because that's the thing that the most common in exam is brass and bronze, right? So let's look at the explanation. Why are alloys stronger? Okay, why is an alloy so strong, and why is a pure metal so soft? It has to do with the atoms. If you look at pure metals, can you see their atoms are arranged very nicely? Okay, the atoms are arranged orderly in layers. You have to learn this. You have to memorize this. They're arranged orderly in layers, so they can easily slide. Okay, they slide over each other easily. That means easily they can slide. You see these layers, since they are so slippery, they are so smooth, they can slide. When they slide, you can bend your metal. This is why pure metal is very easy to bend. It's very easy to deform, right? This is why when we add alloy, when we mix two metals together, can you see now the atoms arrangement? They're kind of like disrupted. You have all these different sizes atoms, mixed together. So now, can you slide? Is this thing slippery to slide? Not so much really, isn't it? Because it's easy, because it's harder. You have all these big atoms blocking. So in this case, they are difficult to slide over. That's why it makes them harder. Okay, this is how your alloy achieve that higher strength due to the non-uniform arrangement of atoms. Okay, so I hope you understand this. Right, so about this chapter, right? If you still remember, I told you this in your paper 2 question 10, there will be an essay question, isn't it? There will be a experiment question, isn't it? And then the question will ask you to write, will ask you to plan an experiment, and then they will ask you to write what is hypothesis, what is the objective, what are the variables. Oh, you got 0 marks for that, right? I have a way to teach you to score. That 10 marks is a free mark for you. No worries, I'll teach you how to score. So and partly I didn't teach you to answer because there's not much experiment going on at the beginning of the year. Okay, so here comes. This chapter they will ask in objective. They will ask in the essay question. So how do you test alloy? Very easy. Can you see there's a copper here? There's a copper block here. So what do? We put a steel ball at the top, and then we drop a weight on it. You see where am I going with this? So when I slam this weight to the ball will create a dent in this copper block, right? Since copper is a pure metal, copper is soft. So if copper is soft, the dent would be very deep. You see, copper, the dent is 4.3 cm. If I change this copper to bronze, because bronze is an alloy, now the dent becomes 3.1, which proves the point that alloy is stronger than pure metal. So this is what hey, this thing, I lost count how many times it came out in the finals. Okay, for the question 11, the experiment question, right? So you can actually read this yourself lah. How do they write problem statement? How do they write hypothesis? There's a formula one. Yeah, there's a formula. Have I taught that formula before? I haven't, right? I haven't, right? I believe I'll do that before your final year exam. I'll do that before your exam because we need to study all the chapters first. We need to, collect all the chapters first. Only I can teach experiment because different experiments has different ways of writing. There's a formula one. There's a formula. If you follow the formula, the 10 marks belong to you. Wow, sounds so easy, right? Because it is. Right, so this is your, to compare the hardness. Next, how do we compare whether they corrode or not, the resistance to corrosion? We use one iron nail, we use one steel nail, we put it in water. So according to plan, this iron nail would rust first, right? Because it's a pure metal, so they rust first. So steel nail, they will last, just a little bit longer. There. Okay, there you go. This is your resistance corrosion ready. Right, so the experiment, I will go into that, in a few months' time, so don't you worry. Next, let's look at your superconductor alloy. Okay, what is a superconductor? This part, don't focus, not coming out in exam. Even if they do, it's very rare. So what is this? A superconductor. Okay, what is a superconductor, first of all? It is a conductor that has zero resistance. Okay, it is a superconductor because it conducts electricity super well. That's why we call it a superconductor, right? So certain alloys, they can be used to make superconductor. So what do we use this for? We use this to make maglev train. Now, what is a maglev train? This is also what we call a bullet train. How can bullet train move so fast? Okay, just in case you don't know, bullet trains, they are stupidly fast. Okay, they are stupid fast. They are around 300 to 500 kilometers per hour. Okay, to put that into real life application, if you were to take bullet train from here to Singapore, it would take an hour tops. All right, you can reach Penang in an hour too. They were going to build one, right? Okay, the high speed rail HSR. Najib was going to build one, and you know what happened to him, so we kind of scrapped the plan because according to Mate, we couldn't afford it. Okay, which is a shame. Okay, because I was really excited for this. Imagine from here to Singapore in 1 hour. It's nuts, man. Well. Okay, maybe they'll revive this, I don't know, Maybe after this election they'll revive this. I don't know. Right. So how can they move so fast? All right. If you have taken a train before, you know how noisy it is. Okay, because there's a friction between metal and metal. But maglev train is different because they are floating. They use this superconductor to create such a strong magnet, they can make this train float on top of it. That's why bullet train can move so fast, because they have zero friction. Okay, the train tracks has no friction. It is floating on the track. That's why they can fly so fast. Okay, not to mention so stable. You see, when a bullet train moves, they are so stable. Let me load this real quick. They are so stable that your pen and coin, are there any hazards? Yeah, they will. Okay, first of all, it's quite dangerous if you don't know how to manage this thing. Okay, and not to mention it's very expensive. Really expensive. But the point is, this is very convenient. It's very convenient. You see how steady they are. They are very stable. The thing is, it is very expensive to maintain. Very expensive to maintain. So for countries like Japan, they can afford it. And for countries like, here's the thing, since this train is flying so fast, right? Japan is prone to earthquake, right? So they have a system to stop this train when there's an earthquake. You see, that's the amazing thing. In Japan, right, most train they have earthquake detector. Whenever there's a shake, whenever there's an earthquake, they will immediately emergency brake their train so that they don't derail. See? So that's their smart design. Right? We can only wish lah, we can only hope lah, but they're not gonna revive this anytime soon, I foresee. Right? So you can also use this magnet to create an MRI machine, which also uses magnet. This is to scan whatever you want to scan in your body. Better than X-ray because it has lower radiation and you can see more things. MRI, you can see a lot of things. Okay, you can scan a lot of things with your MRI. So that's what makes them, powerful and not to mention expensive. Right, so this is your alloy. Okay, this is your alloy. Really simple, isn't it? Really, really simple, isn't it? Nothing really much to say here. The important points are already pointed out. So this first page is all you need to know. It's all you need to know. And if you want, go and read the essay. Read how they write the procedure. How did you manage to score 0? How do you score 10 then? Go and read. Okay, go and read. I mean, I'll give you the formula next time. There's a formula to write one. Anyhow, let's go to our exercise. Okay, let's go to our exercise. Sorry, let me erase this real quick. Let us go to our question 1. This is page 8. Right, so as you can see, the questions, they are very straightforward. Give a definition of alloy. So what is alloy? Alloy is a mixture of several types of metals. Okay, you mix a few metals together, you get alloy. All right. Of course, you need experiments lah. How do we come up with all these alloys that we have today? Is by experimenting. Okay. And so far the one we use is like what, stainless steel, okay, the one we use most widely. So B, fill in the blanks with the correct word. What is a process of mixing foreign atoms into pure metal? So the mixing to get alloy is called alloying. The process is called alloying. The mixture of metal is called alloy. Okay, this sounds like a stupid question. Why are they asking it twice, right? Because they already asked this here. Okay, so the metal and other atoms added is called alloy. So number 3. So this is what happens to pure metal. They will slide. In pure metals, atoms are arranged neatly in rows. Each row can slide over each other easily. Hence, pure metal is softer and easy to bend or easy to shape. You can bend it to anything you want. That's the thing about pure metal. This is why you don't use pure gold in making. Oh yeah, about this, right? Last time, Olympic used to be made from pure metal, pure gold. The gold medal used to be made from pure gold. So this is why pure gold is so soft, they will bite the medal. Right? I mean, you see Olympic, when they win a medal, they would bite the medal, right? They still do it, even though it's not pure metal already, but it's sort of like it's like a very signature move lah. So they still do it. They don't use gold anymore. In fact, your gold medal is most likely going to be made from brass because it looks gold, and real gold is really expensive. Okay, what your point is not the medal, what your point is the pride, what, right? I mean, if you're Usain Bolt, I think you could give jack shit about what the medal is made of because you have 3. I mean, who the hell doesn't know who Usain Bolt is, isn't it? Okay, his world record is more than enough to prove. Okay, he doesn't need to bring out his medal. You will know who Usain Bolt is, right? So anyway, number 4. So when you mix your foreign metal inside, you disrupt the arrangement. So now they can't slide. So the addition of foreign atoms. Okay, the addition of foreign atom into pure metals prevent the row of atom from sliding over each other, so they cannot slide. This is because the added atoms are of different size. You see, one big, one small. That's how they cut out the arrangement. So alloys are harder, not stronger. They are harder, but harder and more resistant to corrosion. If you want to write that, oh, but it's very long. Okay, let's just write stronger. Okay, let's just write stronger, because actually harder doesn't really mean stronger. You see, diamond is very hard, but is diamond very strong? Not so, because the harder something is, the more brittle they are. You see, glass is harder than plastic, but is it stronger than plastic? I don't think so. Would you want to make your car bumper using glass? No, you won't, because they will shatter. Okay, so three purpose of alloying, as I said, is to increase hardness, to make it harder, to inhibit corrosion, okay, to prevent corrosion. Okay, prevent corrosion. Next is to improve appearance, to make them look nicer. Okay, improve appearance. So we have three functions here. Of course, in the exam, they will ask you to write three. They will ask you to write two. Most likely, they will ask you to write two. Okay, easy, right? You see, what you see is what you get. Whatever you learn just now, you just apply it here. There's no twist and turn question. So, number two, there it comes. You see, copper and zinc, copper and tin. You know what is this, lah? So P is your brass. What's copper and zinc? Q, copper and tin, this would be your bronze. Okay, tin is the bronze. Okay, so what is a foreign atom in steel? Right, you look at steel, right? Who is the foreign atom? Foreign atom is the lower percentage one. The higher percentage is the main ingredient. So in this case, you have your carbon. Right, so carbon. Next, number three, name the process involved in making alloy. So to make alloy, the process is called alloying. Okay, alloying. So compare between pure metals and alloy. Basically, they're asking these three functions. Okay, alloy is harder. Okay, harder, more resistant to corrosion. Okay, more resistant to corrosion, more attractive. So we have three here. Okay, basically the three function. So next, number three, photograph below shows two objects. Oh, I don't need to write BM today, so there's no wonder we are so fast. Okay, so as you can see, object P is brass. And then Q is bronze. Right, so B, give two other uses of the alloy used to manufacture P and Q. So what else use you can do? So P, you can use it to make keys, say, use it to make doorknobs. Whereas your Q, they are used to make coins, monuments. Oh, our Tugu Negara, I think it's made from bronze. If I'm not mistaken, our Tugu Negara, if I'm not mistaken, it's bronze lah. Okay, so the oxidation here is kind of different because we have different weather. That's why they look black. Okay, so is it made from gangster? Yeah. So this is bronze also. This is bronze. So why do they look different color from the Statue of Liberty? Because of our different weather. Mostly, you see most sculptures, if they're made from metal, mostly it's bronze, because bronze is, I wouldn't say cheap, but it's the cheapest among other, atoms, other metals, right? You can use stainless steel, but it's very expensive. Okay, so C, why is a bronze block stronger than a copper block? So this is the sliding thing already. So bronze block, they have uneven atom arrangement. Okay, that means the atoms, they are simply arranged. So due to different size of atoms, when you mix copper and tin, let's say copper and tin has different size, so they kind of disrupt the arrangement. So they are difficult to slide over each other. Difficult to slide. So that's why they remain hard. All right. So you see, it's the same as what we learned just now. So D, in your opinion, can the alloy which is used to make object P be used to build a ship? Can you use P to build a ship? Yes, you can, but that would be a very expensive ship. Okay, yes, you can. Yes. Okay, explain your answer because it is harder than pure metal. It's harder than pure metal, so you can use them. Better than using iron, but mostly we use steel, okay? We use steel. Steel is the most used metal. Right, so number 4. This is our experiment I showed you just now. We use copper or bronze block here. We put a steel ball and then we throw a weight on it. So copper, as you can see, the dent is bigger, bronze smaller because bronze is harder. So manipulated variable, what is our MV, which is this, our type of block. Okay, because we're changing copper and bronze. And then responding is this, the diameter of the dent. Constant variable, you can say the weight, the mass of the weight, the height of the weight, the size of the steel ball, the measurement of the block, okay, mass of weight. Right, so B, state one hypothesis for this experiment. Okay, but this experiment, right, you cannot say more. The more alloy, the harder. No, you just write the prediction. Alloy is harder than pure metal. Right, or you can say alloy is I think that's the answer. Alloy is harder. So C, state one inference. Why is alloy harder? Okay, because the layers of atoms are more difficult to slide over each other. Okay, harder to slide over each other. That's why they're harder. Okay, alloy is harder. Again, very repetitive question. So I'm not gonna bother with all these. Let's finish this, shall we? Okay, let's finish our question 5. So study to show the resistance of steel towards corrosion. Okay, so we use steel nail and iron nail. 3 days later, you should see rust here and not rust here. So write down one observation for the experiment. You can say iron nail rust after 3 days. Okay, why? Write down one hypothesis. You can say pure metal, or hypothesis, sorry. You can say alloy. Alloy is more corrosion resistant than pure metal. Right? Or the first one, you don't want to say iron nail rust after 3 days, right? You can say steel nail remain the same after 3 days. Okay, no problem. So our CV, constant variable, would be the volume of distilled water, the size of nail. Oh, I cut that as well. Okay, I'm just gonna say size of nail. If I use a longer nail, then maybe it will rust faster. Manipulated, what are we changing? Which is the type of nail. Okay, we use iron nail and steel nail. So D, predict the condition of the steel nail on the 5th day. You can say no rust, does not rust, or rust a little. I would accept. Steel, they can still rust, but much slower lah. So operational definition for an alloy. Okay, I don't know whether you see this in exam before. When you see this word, oh my God, many don't know how to do. All right, so first of all, when you see operational definition, right, let me teach you how to write. So let's see what they want first. They want the definition from alloy. So you just begin with alloy is whatever definition they want, whatever word they want, you write back the word first. Something is, that's the first step. Okay, if they ask for operational definition of pure metal, they say pure metal is. If they ask for operational definition of what did we learn last chapter? We learn atom. Okay, operational definition of atom is, you start from here, and then number 2, you choose. Is it a process? Is it a thing? Is it a factor? What is it? So alloy is a type of metal, right? Okay, a type of metal, right? Okay, so or you can say a material, an object. Okay, so alloy is a type of metal. And then number 3, you write your definition based on your RV, based on your responding variable. So what's your responding variable? Your responding variable is whether they rust. Okay, whether they rust. So iron nail, they rust. Steel nail, they don't rust. So that's your RV. So alloy is a type of metal. You see, what's the observation? You can use RV or observation. So what's the RV of your steel nail, of your alloy? They don't rust, right? Observation is they don't rust, right? So it's a type of metal that does not rust after 3 days in water. Because does not rust after 3 days in water, this is your observation or your RV. So you use, basically operational definition is to write definition using your observation or using your RV. So that is a 3-step thing. Okay, write back what you write back what they want, define what is this, and write using your observation. Okay, this takes practice. If you cannot get this at the first try, it's okay. Okay, I will repeat this before your exam, your final exam. Maybe by the time you should be able to answer these are questions. Right, so I believe that's it. Okay, since I didn't write in BM today, so I write slightly faster. So we end slightly earlier also lah. Right, so let me emphasize this again. This part is very important in exam. In fact, this whole chapter, next week, right, we are learning glass and ceramic. There are 4 types of glass. Okay, yes, there are 4 types of glass. Okay, just so you know. And then ceramic, and of course, we will learn polymer, which is plastic, and we will learn rubber. Okay, so the main point for this chapter, the most important point for this chapter is going to be alloy and rubber. Okay, this rubber thing, maybe I'll go into this next week if I have the time. All right, so I hope you learned something new today. I'm going to call it a day lah, since it's a very easy lesson. So if you have no question, then I shall see you next week. All right, so yeah, welcome, no problem. I'll see you next week. So see you, take care. Bye-bye.